Good evening. Good evening. So good evening, everybody. Let's join it fast. Hi, hi, everybody. Hi, how are you, everyone? So yesterday I taught you about vector, scalar, and vector quantities. So just for few minutes, within few minutes, we will recall the all topics which I taught you yesterday. So yesterday I taught you in the vector and scalar quantities. So in second chapter I taught you first a scalar. What is a scalar? A scalar, those physical quantities have only magnitude, no direction, that is known as a scalar. Then I taught you the tensor. Tensor, what is tensor? This is a those physical quantity have a different values in a different direction at a same point, that is known as a tensor. Then vector, I taught what is vector. So those quantities have a those physical quantities have both magnitude as well as a direction, that is known as a vector quantities. So after that, how many types of vector quantity I taught? There are two types of vector quantities. One is a polar vector, another is axial vector. What is polar vector? A polar vector is known as a vector have a starting point, that is known as a polar vector. And axial vector, the axial vector represent the rotation effect, that is known as a axial vector. And I told you yesterday other types of vector like equal vector, negative vector, zero vectors, are null vectors. Zero and null are equal to each other, both are same. We can say zero or we can say null. And then I taught you unit vector, algorithm vector, co-initial vector, co-linear vectors, coplanar vector, localized vector, non-localized vector, position vector, and displacement vector. So now we are going to discuss about addition of vector. Today we will discuss here addition of vector and subtraction of vector. So addition of vector have a many topics. First we will discuss about the triangle law of vectors addition. Then we will discuss about the parallelogram law of vector addition, and then polygon law of vector addition. So in that some topics are there, so we will discuss like a rotation of vector and resolution of vector, direction cosine of vector. Then last topic we will discuss today, subtraction of vector. So let's start our study today. So addition of vector, in that first topic which we have, triangle law of vector addition. So if two vectors acting at a point are represented in a magnitude and direction by the two sides of a triangle taken in one order, then their resultant is represented by the third side of the triangle taken in the opposite order. Now you can see the figure. The first vector A, and the second vector R. Between vector N and vector R, the angle is creating, that angle we consider as a beta. That angle considered as beta. Here two side of triangle taken in one order. So both vector, if you see, the initial point from vector R is starting from the initial point, and also the vector A both have a initial point at a same point, and both are moving in a direction, in a same direction. And after that, then their resultant is represented by the third side means vector b of the triangle taken in the opposite order. This is the opposite order to the vector a. So here we can take a component of vector addition b. We will take as a component what b sine theta as well as the b cos theta, b sin theta as well as a b cos theta. Now, if two vectors a and b acting at a point are inclined at an angle, then the resultant, what we will write? Resultant r is capital R we will write for the resultant. So resultant equal to root under a square plus b square plus 2ab cos theta, 2ab cos theta. Now, if the resultant vector r subtended an angle beta with vector a, then tan beta, then what we will write? Because we know that sin theta upon cos theta, it becomes tan theta. So tan beta, this angle here you can see this angle creating between two vector r and vector a, the angle is creating, that angle is a beta. So here another vector we are getting na. So this third side of the vector, that this vector is known as a beta vector. So sorry, b vector. And so for the b vector we are getting two component, one is a sine component, another is cos component. So b sine theta and b cos theta. So according to that, here it is written the total resultant vector subtended an angle beta. Which angle? An angle beta. Yes or not? With a vector a. Which vector? This vector. This is a vector a. So with vector a. So then what we will write? What is the expression? So tan beta equal to beta b sin theta upon a plus b cos theta. Next, parallelogram law of vector addition. Parallelogram law of vector addition. Now, so here we can see if two vector acting at a point are represent in magnitude. Two vector. So vector b, if you see in the diagram, so vector b and vector a. Yes or not? So here it is written if two vector acting at a point. So at a point they are vector b as well as a vector a also, and then represented in a magnitude and a direction by the two adjacent sides of parallelogram draw from a point, then their resultant is represented in a magnitude and direction by the diagonal of the parallelogram drawn from the same points. So here between beta vector b and vector a, so one angle is creating between vector r and vector b, that angle is theta. From vector b and vector a, between vector b and vector a, one angle is creating, that angle is known as a theta. But if you will see this diagram, then the vector r and vector a, between vector r and vector a, one angle is creating, that angle is smaller than the theta. So this angle is taken as a beta. And here the closing, the third side of the triangles, third side of the triangle vectors. So here in the third side of triangle vector, consider as a vector b. So here two component b sin theta as well as the b cos theta. So resultant of vector a and b is given by r equal to, r is what? So R is a resultant. Capital R we are writing to denote the resultant. So capital R equal to root under a square plus b square plus 2ab cos theta. If the resultant vector R subtended an angle beta with vector A, then tan beta equal to b sin theta upon a plus b cos theta. A plus b cos theta. Now next one, polygonal law of vector addition. Polygonal law of vector addition. So in states, it states that if number of vectors acting on a particles at a time are represented in a magnitude and direction by the various side of an open polygonal taken in same order, then their resultant vector is represented in magnitude and direction by the closing side of polygonal taken in opposite order. In fact, polygonal law of vector in the outcome of triangle law of vector. Now here we can see in the polygonal law of vector addition in the diagram. So O is a origin point, and it is a this O point is a initial point for the every vector, vector R, vector A, vector B, vector C, vector D. So every vector, also vector B, also vector C, vector E. So for the every vector, this O is a initial point. This O is a initial point. So here it is written open side. Here it is written various side of an open polygon take in the same order. So if you see from O to A, vector A from O to A, after that A to B. So this is the open side of the polygonal vector. So this polygonal vector B vector is the opposite direction to the A vector. Same direction to the A vector. But again, if you move continuously from A to B and B to C, C to D, and E to D to E, then D2 is a closing side of polygonal. So it's taken as the opposite direction of the vector R as well as the vector E. Are you getting yes or not? Yes, I hope. So here it is in the polygonal law of vector addition, it is stated that the vector A and vector B. So between the vector A and vector B, the open polygonal is here. So in this vector B third side, vector B considered as a third side. So this third side is open. So in A vector, direction is similar to the B vector. But here in the vector A and vector R, so both have a different direction because it is a closed polygonal. So that's why here the vector is taken opposite to each other. R vector and E vector both are opposite to each other in polygonal vector. Now here we can say, so capital R we are writing for the resultant. So capital R equal to A plus B plus C plus D plus E, because the 5 vectors are here in the polygonal. So that's why we have written a total resultant equal to A plus B plus C plus D plus E. So we can consider here, or we can write resultant for the resultant vector, for the resultant what we can write OE is the resultant. After that OE, then we will consider OA, then AB, then BC, then CD, then D. Now next we are going to discuss about the properties of vector addition. Now, so the addition have some properties, so we will discuss now. First point for the properties of vector addition is given. Vector addition is cumulative, that is a plus b equal to b plus a. Vector addition is associative, that is a plus of b plus c equal to b plus of c plus a equal to c plus of a plus b. So this is a associative addition vector. Next, vector addition is the distributive. Vector addition also known as a distributive, commutative, as well as a associative. So vector addition is a distributive, that is m into a plus b equal to ma plus mb. Fourth one, a plus not equal to a. So now next one we are going to discuss next topic which we have, rotation of a vector. Rotation of a vector. So first point, if a vector is rotated through an angle theta which is not an integral multiple of 2 pi, the vector changes. So in the rotation of vector, here through an angle which is not an integral multiple of 2 pi, the vector changes. Because why it is not rotated, why it is not integral? Because every time the vector is changing. We have seen in the polygonal vector. So every time the vector is rotating, yes or not, vector is changing. So that's why in the in rotation of vector, we can say in the rotation of vector, the vector always changes. That's why here whatever the angle is there which is not an integral multiple of 2 pi. Second point, if the frame of reference is rotated or translated, the given vector does not change. Suppose in case in the rotation of vector, the vector is changing from the reference frame. Then vector does not change. First point, every vector is changing. If vector is changing, then what happened? Then whatever the angle is there between two vector which is not an integral as well as multiple of 2 pi, but if vector is rotating, changing, vector does not change, then component of the vector may be however change. So whatever the component, how many components? Two component. One is a sine component, another is cos component, yes or not? So component it may be changed. Now next one, resolution of vector into two components. If two components vector of r, so r capital resultant are OP and PQ in the direction of A and D. In the direction of A and D. Now, so this diagonal is a resultant. This diagonal is resultant. OQ is a diagonal, and this is considered as a resultant. So this resultant is in the direction of A vector as well as a B vector respectively. And suppose OP means A vector and PQ means B vector, PQ means B vector. Okay, so here OP is equal to gamma A and PQ equal to mu B, where gamma and mu are two real number. Where gamma and mu is, what is this? This is a real number. Okay, now next one, then the resultant vector of the resultant vector of the two component is r equal to gamma a plus mu gamma b. Now resultant resolution of a vector into rectangle component. Resolution of a vector into rectangular component. So we know that every vector have a two component. One is a cos component, another is sine component. So horizontal component, if any vector a subtended an angle theta with x-axis along with the x-axis, then its horizontal component. So this O2x is known as a horizontal and O2y is known as a vertical. So here the x component along with the x-axis, the component is ax equal to a cos theta, and vertical component for this diagram for the rectangular components, the vertical component is ay equal to a sine theta, a sine theta. Now so magnitude of vector a, because a is a diagonal between y-axis and x-axis, so that's why here a equal to root under ax square plus ay square. Now y-axis is represented as a ay and x-axis is represented by ax, a base x, a base y. So tan theta equal to, we know that sin theta upon cos theta becomes tan theta. So tan theta equal to a base y upon a base x. Yes or not? Good evening. Now next one, angle theta equal to tan inverse ay upon Im. Yes. Welcome Urjit to join us. Good. So angle theta equal to tan inverse into a base y upon a base x. So through this diagram, a base y, it's represented as a y-axis, and a base x, this is represented to the x-axis. Between the y-axis and x-axis, there is one diagonal. That diagonal is a. So a equal to magnitude of vector a equal to root under a base x square plus a base y square. Now move ahead. Next topic which we have, direction cosine of a vector. Direction cosine of vector. So if any vector a subtended angle beta, alpha, beta and gamma with x-axis, y-axis as well as a z-axis. So this here in the direction cosine of vector we are discussing about the 3D. We are discussing about the 3D means 3-dimensional, 3 direction. Okay, 3-dimensional we are discussing here, alpha, beta and gamma. So with x-axis, y-axis as well as a z-axis represent respectively, and its component along these axis are a base x, a base y and a base z. Then cos alpha equal to, so see here, so here the three axis, one is a y axis, another is x axis, another is z axis. So between the y axis and z axis, one vector, that vector is a. So this vector, so angle is creating between vector a to axis, x axis, between vector a and x axis, and another angle is creating vector a to z component, z axis, where z axis. and another angle creating between found between y axis to y axis between a component, y axis and a component. So between which angle is formed between y axis as and a component, a vector, then that angle is known as a beta. And which angle is creating formed between a vector as and x axis, that angle is known as a alpha. And which angle is creating between vector a to z axis, that angle represented with gamma. So here we can write cos alpha equal to a axis, a base x upon a vector cos beta. Cos beta means what we will write, cos beta equal to what we will write, a y, because horizontal vertical we will take. So first vertical we will take, so a base y upon a vector, then the cos gamma. So cos gamma equal to what we will write, first we will write a base z, a base z, after that upon what we will write, vector a. Now then, so cos square alpha plus cos square beta plus cos square gamma equal to 1. Now next one, so today, so last topic we are going to discuss here. So this is the last topic in vector scalar and vector addition. So tomorrow we will discuss next topic in this. So this is the last topics, subtraction of vector. Because now we have discussed, later we will summarize the topics, whatever the topics we have studied today in live session. So last topic which we have, subtraction of vector. So what is subtraction of vector? Subtraction of a vector b from a vector is defined as the addition of vector minus b negative of vector b to vector a. So this vector a minus b equal to a plus minus b, a plus minus b, because it is a subtraction of vector. So in the subtraction of vector we are doing that, we are subtracting the vector b from a vector a is defined as the addition of vector minus b. So that's why here it is written a minus b equal to a plus of minus b. So today in this live session I taught you about the addition of vector as well as the properties of addition vector and types of addition vector. We had discussed 3 types of addition vector. Today first is the triangle law of vector addition, second is the parallelogram law of vector addition, third is polygonal law of vector addition. After that I taught you about rotation of vector addition, then resolution of vector addition, direction of cosine of a vector addition, as well as the last topic which we have discussed right now, that topic is subtraction of vector addition. So tomorrow we will discuss the next topic which we have, multiplication of vector addition. In that we will discuss about the dot product, cross product we will discuss. So that's all about today. Thank you for joining me, joining my YouTube channel. So please keep learning, keep studying, keep joining, keep sharing, and subscribe my YouTube channel and share my YouTube channel to your friends group, in your WhatsApp group. Thank you. Bye bye everyone.